Dr. Bhaskar, Assistant Professor, Department of Computer Science and Engineering, Anna University, Chennai. Area of specialization is software engineering and database system. Guided more than 12 research scholars, published more than 40 national and international papers. Is a reviewer and editorial board member in international journals.
Welcome to UGC lecture series in computer science. In this series of lectures, we have been looking at software engineering as a subject, and for today's session, we will be discussing majorly on software quality assurance. To understand the exact meaning of quality, let us define what quality means. By a standard IEEE glossary, quality is defined in terms of degree to which a system, a component or a process meets specified requirements and customer or user needs or expectations. As we have already understood that as part of acceptance testing, whatever the end user has posted as a requirement, those specifications are to be initially met. So, during the process of development, as a process or as a system or as a component, everything should be maintained or developed in terms of quality. So, quality is being given a high importance as a product development phase. So, a customer or a user needs or expectations is to be exactly met is a primary objective of defining a quality. ISO's definition to quality: the totality of features and the characteristics of a product or service that bear on its ability to satisfy specified or implied needs. Here we have two specific points, one mentioned as feature, the other key point is the characteristic. Any product that is to be mentioned in terms of features or the characteristics and sometimes and the characteristics, both features and the characteristics put together, it need to satisfy the entire of the customer needs. So, that is why they have defined the totality of features and characteristics of a product or service that bear on its ability to satisfy specified or implied needs of any specific customer. As an alternate view to the quality, quality is not an absolute value. Quality is multidimensional and can be difficult to quantify. You would have heard to some of the people words as two different things, one is quantification, the other one is qualification. Quantification is in terms of the number of, either in terms of documentation when we say the number of pages got added as and when the product got developed, and quality is something that is produced as per the expected needs of the customer or the end user. So, this quality is multidimensional and can be difficult to quantify. Quality has aspects that are not easy to measure. Quality is assessed and is subjected to constraints. Say for example, if at all a project need to be clearly defined, it is in terms of the cost. Say cost can be one of the quality measure that we might project, time can be other quality measure that we can project. Say when a product need to be developed, we take up certain aspects, say schedule, time, budget or the cost. Say appropriate amount of time we may have to complete the project, that in turn is dependent on the quality of the product. With the given set of cost we are about to complete a product, that again is a point on the quality of the project. So, we take an assessment on the subject of constraint which is mentioned as cost, time, etc. Quality is about acceptable compromises. there is no certain compromise on the quality, but then if it is acceptable by the end user community or the person who exactly wanted this kind of a product to be developed, then this is acceptable compromise. Say, when we wanted to talk more about quality, there is one certain quality imperative which is keen towards the understanding of these kind of process development is your Six Sigma. Whenever we talk about Six Sigma, it is about to minimize the total amount of defects involved in terms of product development. Say the number of defects that got reduced as and when the process of the entire product development got improvised. So, which again has the intent to find on the quality. So, the other criteria of quality are not independent and can conflict. Some of the quality criteria as part of this quality assurance include correctness of product development, efficiency of product development, flexibility, integrity, interoperability, maintainability, portability, reliability, reusability, testability and usability. If you could recall one of the assignments that I have given in the beginning, as if you are very good at the language with which you are about to develop your product, basically to understand it from a common man's perspective, English is being used as a communication medium. So, in English, if you are very good at basics of English and add on top of it words ending with ty or lity, that will give you a clear distinction on what kind of products that are to be developed in terms of quality. So, when you look at most of the points that I have mentioned here, flexibility, integrity, interoperability, maintainability, portability, reliability, reusability, almost all the words are ending with ty. Correctness is something that whatever the end user has mentioned and we could adopt to those constraints and values that the end user has maintained is called as a correctness. And to the highest level of satisfaction which we provide to the customer, it is called efficiency. Flexibility is something that which we maintain as part of say password setting. So, when we wanted the password, we could either accept the password which has got less strength and accept which has got more strength also. Integrity is a part of viability that we will provide on a product. Interoperability is something switching between the domain, how well we operate. Maintainability, which plays an active role after it is being delivered to the end user's expectation. Portability, how portable this will be when it is getting deployed over different variants. Reliability, how reliable is this product workable under different environmental conditions. Reusability, can this product developed under this circumstance be reused into another product of different version, or at least some component of it can be reused for building up basic components of the next level of product. Testability and usability. So, now we are coming to today's session where we wanted to understand the assurance of quality towards the software. So, it has been given under the title software quality assurance. It is a set of systematic activities providing evidence of the ability of the software process to produce a software product that is fit to use. Anything that is fit to be used as a product is basically called a quality assurance, and something that get produced as part of process divided in terms of components and is being systematically activated over a period in time, so that all the products are made to be fit for use. So, that is how this definition turned out, a set of systematic activities providing evidence of the ability of the software process to produce a software product that is fit to use. So, this definition is being given as part of Software Quality Handbook published by Prentice Hall. So, as part of software quality assurance, we have one of the process which is called monitoring process and products throughout the software development life cycle to ensure the quality of the delivered product. It is not just the product that is to be maintained, it is also the process that are to be maintained over a period in time. Say when we try to compare between systems which got developed way back in 2000 and 2010, there has been a large difference. I will give you a very simple example. Anything that has been mentioned as username and password were acceptable in the beginning, say in the beginning of 2000, and people who wanted to obtain a username and password as on today have different options. Say this particular password is already existing within the database of any system, then they might have to change the username and accordingly they might have to set the password, which should be of either less strength or high strength, which is a combination of different characters, different alphanumerals, different possible keywords that we might have to give with. So, monitoring the process and the product throughout the software development life cycle to ensure the quality of delivered product. So, this software development life cycle, as we have mentioned at the initial days, is about the analysis, design, implementation and testing phases, where quality is not before giving it for operation to the end user. Quality comes from the process level of requirements analysis and specification, and it flows through the design, it flows through the implementation as part of coding, and it flows through the testing as part of the different test plan, test imperatives and other aspects, and having given as operation as an acceptance test, how well it could work on the hands of the customer. So, the entire process is being monitored for its quality, and as a whole, as a packaged system, the entire product again is being maintained for its quality. So, whenever we wanted to monitor the process, it provides management with objective feedback regarding process compliance to approved plans, procedures, standard and analysis. So, there has been certain approved plans, procedures, standards which are given by the superordinates of a company. Say for example, we might have some best practices which are to be followed as part of software development. So, adopting to the standards that the best practices used to provide us is being a continuously monitoring process. So, it provides the management with objective feedback regarding the process compliance to the approved plans, procedures, standards and analysis. The same when it comes to monitoring the product, it focuses on the quality of the product within each phase of the software development life cycle. For example, it starts out with the requirements, creating the test plan, drawing the high level architecture and going for the module design and etc. So, the objective is to find out, identify and remove defects throughout the life cycle as early as possible. So, the initial objective of this particular monitoring process is to understand, identify and remove as far as or as many defects as possible throughout the entire life cycle. Let us have a short break. Welcome back after the break. I was discussing about software quality assurance. We were looking at monitoring the products. So, as an objective of monitoring the product, our intention is to identify and remove the defects throughout the life cycle, by where we ensure the quality on the product. As I have said, Six Sigma is being a quality imperative which will take you defect free environment, where from 99% of defect free to 99.99% of defect free environment. We will not be able to say that this product is 100% defect free, it is independent, or it is basically dependent on the customer needs. We cannot always say that 100% we could satisfy the entire requirement posted by the end users, but then we will be able to justify saying that 99% of the time I may be able to stress on the quality. Now, we will talk about quality of software developed in-house and commercial off-the-shelf components. The COTS refers to commercial off-the-shelf components. SQA processes apply when integrating purchased or customer supplied products into a developed product. So, this software quality assurance processes applies when I am trying to integrate, either I wish to purchase the entire product from a different kind of an industry, and on top of it I work and I will develop on my own so that it becomes customer centric, or I might go in for some customer supplied software products which gets developed over the period. So, now the question which turns up as part of this kind of a development is, how do we determine the quality of customer off the shelf components, which has been a major current research problem which people are trying to carry it out. So, some of the product assessments that we come across: as part of assessment we do reviews, inspections, walkthroughs, where some of the specialized techniques that are available as part of these three phases, which imply how to review or assess the requirements, how to review or assess the architecture, detailed design, implementation, the different test plans, the different acceptance, the different system and other things. The assessment is in turn dependent on the testing, simulation, prototyping, formal verification, where we have model checking, theorem proving and etc. Say, as part of simulation, we might try to understand how exactly this might be a replica when it has been developed as a real world product. So, simulation, which is just a replica of what exactly need to be developed in a real world. So, as part of product assessment, as we have already mentioned, reviews, inspection, walkthroughs of plans, reports, models, standards are to be adopted, where my concentration would be on the project management. This project management I have told you in terms of both program evaluation and review technique and phases by where we identified the critical path method. Quality assurance, training, test plans, and we have started with the entire software development life cycle, where we begin with requirements, analysis, architecture, detailed design model, test case development, etc. And issue or problem reports are to be identified. So, wherever there is some defect that is involved, those defects are to be rectified. Metrics are to be reported, traceability reports in case there has been a heavy possibility of risk or defect, those have been tracked, documentation and coding standards. Use of standards and process models has a positive impact on the quality of the software product. Say, we follow a disciplined approach or a controlled development process over the entire phase of development, software development life cycle, so as to ensure that major quantum of quality is getting maintained. So, some of the examples that we majorly follow to maintain the quality are ISO 9000. So, as you could see, different labels which are coming out with saying ISO 9000 2000 certified company, where they would have adopted to the standards as mentioned by this ISO. CMM, as I have already mentioned, Software Engineering Institute has come out with 5 different levels of maintaining the CMM, and the other standard institute is SPICE, where they develop a standard for software process assessment, and ISO's joint committee either in Europe or Australia, where they ensure on this software standards. IEEE 1074, IEEE 12207 are certain software process assessment standards, and these software reviews may include managerial reviews, acquirer or supplier reviews, technical reviews, inspection, walkthrough and audits. So, as part of inspection, we might do a formal evaluation technique in which an artifact, for example requirements design code, is being examined in detail by a person or a group other than the originator, detect faults. Say after I clearly come out with a requirements analysis and I specify that this is what I will be developing as part of the project, this will be this will be signed in concurrence with the end user. Once after the end user approves on this particular document, this will be provided to one of the customer as a beta level, so that we will try to understand how the customer feels that when this kind of a project is being developed, how successful it will be at the hands of the customer. So, a formal inspection will be done apart from these two kind of development teams, say the developer and the specifier. There will be another audit which will be done purely in terms of a layman's perspective. So, this formal evaluation technique in which an artifact is examined in detail by a person or group other than the originator, detect faults, violations of development standards and other problems where major of the defects are being clarified. Review members are the peer committee members of designer or the programmer. So, the data is collected during the inspections for later analysis and to assist in future inspections. Some of the other review methods which include, say we might post a question of what kind of people, what is the requirement of the people, who are the audience and what is the objective with which this kind of a project need to be answered. Say we have constructed a matrix with a basic understanding of review, walkthrough and inspection question in terms of what, audience and objective. So, with review, the what of the question will be present idea or the proposal, with walkthrough it will be technical presentation of the work, and with inspection it will be a formal review by the peers. And with the audience, as far as review is concerned, it is by the management or the technical team. As far as the walkthrough is concerned, it will be at the technical team. As far as the inspection, it is again the technical team. Whereas the objective that are met during the review are provides a clear information, evaluates specifications or plan and gives a clear picture on the status. As far as walkthrough is concerned, the objective is to explain the work and may have to find the design or the logic behind the defect so as to understand the given context. And the inspection, the objective is to fix and find the early defects. So, as part of quality assurance, we might have to come across a quick quality checklist which is to uncover the defects. So, it is useful to support reviews, inspections and walkthroughs. Expertise is captured in a list format where less experienced people can use, straightforward to use, and it should be clear, simple to assess and apply and improve the consistency of the assessment. Say one specific word wherein we wanted to give utmost concentration is the consistency. Throughout the entire phase of software development life cycle, we wish to maintain the consistency of the assessments so as to unclear all the defects that we have come across. So, example architecture checklist used in the undergraduate and postgraduate courses for object orientation, say spreadsheet in the course materials and the subdirectory for it are the major examples that are to be given as a checklist. One or more architectural styles selected, capabilities and interfaces are determined for subsystems, capabilities and interfaces among the subsystems support all the use cases and concurrency being clearly defined. Say there are situations where we might go across with different architectural styles. There are situations where we might go across concurrency approach, that is parallelized approach. So, those are the places where we might have to give utmost concentration, and there is a specific checklist which are given so that there is a possibility of risk at this juncture that get eliminated. Distribution defined, error handling defined, startup and shutdown clearly defined, data persistence, that is maintenance of particular data getting clearly defined, a rationale for the model is being provided, and all the other imperatives are being taken as the different formats of the checklist for finding out the defect. So, verifying these formal specifications. Formal specification may be verified in a number of different ways. Say for example, I might check for the syntax, I might check for the typo error if the notation is not typed, and I might go for the simulated environment where I might point out the defect, model getting checked, proven checked already has a standard or a benchmark being developed. So, with which I can find out these defects. So, whenever I go with this kind of an approach, if I start with a syntax or a typo, it may be a more straightforward approach, whereas if I check from the proven approach, it is a less straightforward approach. So, from a more straightforward approach, less assurance of correctness, and it is a fully automated system, whereas when I am trying to adopt to the less straightforward approach, it is higher assurance of correctness and not fully automated. Now, I am to talk about problem reporting, tracking and resolving. So, this describes the practices and procedures to be followed for reporting, tracking and resolving the problems. So, where exactly the problem came across, those have to be reported and those have to be corrected. So, that also is again prepared as a checklist, so that how much of rectification is being done, so that I prove on the correctness and the efficiency of the work. So, who can report on the problem is being the first question. How is it reported? How is it tracked? Who determines if it is a problem that is going to be resolved? How is it assigned for a resolution? How does the person indicate it has been corrected? Who reviews it to determine if it can be closed? So, there are a team who work for the quality check by itself. There is a team who will depend on the entire process development, but this quality check is again being done with a specific standards clearly mentioned. So, problems can be a product or a process related. For example, incorrect requirement, incomplete class definition, code defect, ambiguous description in user documentation, process to review, detailed design is not clearly defined, etc. are some of the examples of process or product related problems. And there might be problems which might have come across by use of different tools or different techniques or the training which has been provided as part of the development. So, what tools I try to use, what techniques I try to provide, what training is needed on the tools and techniques that are to be provided to the end user community are also to be given highest importance. So, as part of quality assurance, we might stick on to the metrics also. This metrics, as I have already mentioned, is a random metric that we are proposing, say in terms of correctness, in terms of efficiency also. So, metrics are for each artifact. For example, in terms of requirements, the number of requirements are to be posted, number of changes per requirement which are called as churn rate, characterization of defects, and with all these metrics. So, in summary, we have started with defining quality. We have defined the different quality criteria, those are the T's that I was mentioning to you. We have started with what is quality assurance. I have explained to you about product assessment, software reviews, some of the tools and techniques wherein the defects might turn about. So, we had a separate checklist for software reviews, tools and techniques. Finally, I have explained you about metrics. Some of the questions for this particular session: why is quality given much importance in product development? Is quality essential during process or product development? Let us say or both. What are the major quality criteria? Thank you.